This is R.D. Sharma solution, class 12th, chapter 10, differentiability. MCQ, multiple choice questions we are taking. We have a series here, fx is equal to x square plus x square by 1 plus x square, like this. So there are four options. Who wants to do by themselves? For them I have given a reference. And those who want to understand the logic, just see that. Let me write this series and put value 0, because the function is asking at x equals to 0. The question is also talking about 0. So I am putting x as 0 everywhere. 0 by 0 square plus 1 plus 0 square, that is going to be 0 by 1, that is going to be 0. So all zeros will be there. So it goes up to infinite. When you add this, f0 will ultimately give you a 0 value. When you apply limit extends to 0 on fx, if you want to check the continuity, the limit on this function for this c or any value which needs to be checked, if this is equal to the function value at that value, that is, you have to check at 0. So f0, if it is equal to limit extends to 0 fx, then you can say that this function is continuous, otherwise discontinuous. f0, we just found out it is 0. So let us see this. I am taking x square common from this series. When I take x square common, what is remaining? 1 plus, you have 1 by 1 plus x square. Then we have 1 by 1 plus x square whole square. And this goes up to infinity. Right? Now I am applying the limit extends to 0. And you know that when you have the form like this, you have a series here. For example, you have a plus a square plus a cube, like this. Then what is the sum of the infinite series? It is a upon 1 minus r. The r is a common ratio. A square by a cube by a square, a raised to the power 4 by a cube, like that. This is just I am giving you an example. So this example can be employed, or this result can be employed, which we have learned in the series, geometric series and arithmetic progression, all these. So we have a by 1 minus r, a is 1 here, 1 minus r. If you divide any of the two terms, you get 1 by 1 plus x square. This is your r, common ratio you can call. So I'm taking only the right portion right now. I'm just solving this, then I will apply the limit, etc. So 1 minus 1 by 1 plus x square. So 1 plus x square here, minus 1 divided by 1 plus x square. So 1 gets cancelled. You have x square by 1 plus x square in the denominator. This is in the denominator. When it goes up, 1 plus x square will be in the numerator. X square will be in the denominator. Now this x square was already there outside. So you just cancel these two, x square and apply the limit. When you apply the limit x tends to 0, 1 plus 0 is going to be 1. Alright. So when these two are equal, f0 is equal to 0 and this limit is actually coming as 1. So they both are not equal. So when the initial criteria failed here, so you can just clearly say that this function is discontinuous. Now, if you go to the multiple choice question number 7, we have already discussed this question. So if you have seen that MCQ, you have watched that, you can just skip and go ahead. And for those who want to do this and try to learn in detail, they can refer to multiple choice question chapter number differentiability and question number 7. But I'll give you a hint here, just an idea. See, y is equal to log x. This is the graph of the log x. You have to be very careful about log x, but because this is just an exponential function. But this varies. This varies in negative and positive both. So if you are from 0 to 1, see, log 0 is not defined. So this graph is never going to touch the y-axis. So it is from 0 to 1. When the graph is between 0 to 1, you can see it is on the negative y-axis. From this graph, it is clear. So log x, if you open the modulus, it will be negative log x for the value between, this x should be between 0 and 1, please remember 0 is not included here. But when you go up 1, when you move ahead 1, then you see this graph is positive, so you get it on the positive y-axis. So for that, when you open the modulus, you will get a positive log x. I hope you got the idea. So you have f dash 1 plus, f dash 1 minus. This is the first option and second option. It is not seen here, but the options are 1 plus and 1 minus. So we have checked the continuity, we have checked the differentiability for log x, if you remember. But since the question is asking about f dash, that is the derivative or differentiability, and since they are have given the option 1 plus and 1 minus also, so we'll check at x equals to 1. We will check we will demonstrate the differentiability at x equals to 1. So left hand derivative, when you go on the left hand of 1, you have to use negative log x. And the right side you have to use log x function. The differentiability is given by fx minus fc divided by x minus c. X is tending to c and c is 1 here. C is 1 here. So fx, both functions you know, minus log x and log x, that you know already. What is fc? Just put f1 here in the equality sign function. Log 1 is 0. So if you take log 1, it is going to be 0. So fc will be 0. So we are not going to use it or write it, because we already know it is 0. So fx minus fc is basically fx we are going to write. fc is 0. So this fx minus 0 divided by x minus c. X minus, what is c here? As I said, we are checking at 1. So x minus 1. So finally, the simplified version of this fx minus fc by x minus c is fx divided by x minus 1. I hope you got the idea. That we are going to use in the LHD and RHD both. The only difference will be the function. So when you are on from 0 to 1, that is on the left of 1, you are going to use negative log x in place of fx. Okay? And log 1, of course, as I said, it is 0, so I am not writing it. This log 1 I am talking about. It is 0, I just simplified the function x minus 1. So x minus 1. Because we are taking x tends to 1 minus. When you are at x tends to 1 plus, then you have what? Log x divided by x minus 1 again. So x will be equal to 1 minus h, x will be equal to 1 plus h on LHD and RHD, and then we'll change the limit. Now limit will be now h tends to 0. Here also limit will be h tends to 0. And this is going to be replaced 1 minus h in place of x. So minus log 1 minus h divided by x is 1 minus h. So you have 1 minus h minus 1. 1 minus h minus 1 minus cancel, you get a negative h. Here you have log 1 plus h. So just write log 1 plus h in place of x, replace it by 1 plus h. 1 plus h minus 1 is h. 1 plus h minus 1, 1 gets cancelled. You get a h. Please remember, log 1 plus x by x, limit x tends to 0 is always 1. That we have used multiple times. Since it is negative h, you can directly use negative h in the denominator. It is almost equivalent to the identity I showed you. Negative is outside. There is a separate negative here. So you get a negative 1. Log 1 plus h by h, this also gives you 1. So you have a negative 1 here, you have a 1 here. So f dash 1 plus is 1. F dash 1 minus is negative 1. Okay. So the answer is A and B. I hope you got the idea. 1 plus is 1, this one. And then we have two options for negative 1. So you are not going to choose the last option because it is just saying f dash 1. But we are talking about f dash 1 plus and f dash 1 minus. F dash 1 plus is simply equal to what are you going to get in the right hand derivative. Similarly, the left hand derivative will give you f1 minus, f1 plus and f1 minus. So f1 plus of course is 1. But we have two options for 1. There are two options which are saying 1. We are not going to choose the third option. Same logic goes for f dash 1 plus, which is equal to negative 1, and we also have f dash 1 as negative 1. That also not we are going to use. We will use the second option, which is f dash 1 plus. Okay. I hope you got the idea. But if you want to know this in detail, because we have covered the continuity of this question also, then you can always refer to the multiple choice question number 7, where we have discussed continuity about, and not only the continuity, the function graph. We have made the graph and we have analyzed it, and not only on the positive part but on the negative x-axis also. Okay, this question again, it has taken us more than 15 minutes to discuss. In question number 9 of exercise 10.2, I'll give you the link of the whole playlist. I would request you to please refer to 10.2 question, because we have discussed this in a great detail, how this log x, log modulus x and modulus of that log x, how does it unfold. Okay. Now fx is equal to 1 by modulus x for modulus x greater than or equal to 1, ax square plus b for modulus x less than 1. Now the question is saying this fx is continuous and differentiable also. So you have to find out the value of a and b. So modulus x less than 1 means what? And modulus x greater than or equal to 1 what? Modulus x less than means x is less than 1 or a negative x is less than 1. So negative x less than 1, multiply both sides by negative, so the sign, the inequality will change. So x is less than 1 and x is greater than minus 1, that is what modulus x less than 1 says. So in order to understand it graphically, you have a negative 1 here, you have a 1 here. So anything between negative 1 and 1, where my negative 1 and 1 are not included. Okay, that means it is modulus x less than 1. So now you are talking about modulus x greater than or equal to 1. What does it mean? It means you are talking about values which are less than or equal to negative 1. Same thing what we have done for modulus x less than 1, you can also do it for modulus x greater than or equal to 1. Modulus x greater than or equal to 1 means x greater than or equal to 1 and negative x greater than or equal to 1. And that will give you x is either less than or equal to minus 1 or x is either greater than or equal to 1. For x greater than or equal to 1, you will get 1 by x. For x less than or equal to negative 1, you will get negative 1 by x. So we have three boundaries. One is negative infinity to minus 1. The other is 1 to infinity and the other is negative 1 to 1. So I am doing the modulus x greater than or equal to 1. That is x is greater than or equal to 1 and negative x greater than or equal to 1. It may be, both are there, because when you open modulus x, it will be the negative x greater than or equal to 1, you multiply both sides by negative sign. So it is going to be x is less than or equal to negative 1. You know the inequality change when you multiply by the negative sign. So you are talking about negative 1 and left, 1 and right. So when you go up 1, you will get 1 by x. When you go below negative 1, you get negative 1 by x. Okay. So we have a function modulus x greater than or equal to 1, which is actually saying as greater than 1 or less than minus 1. And since we have a 1 by modulus x, one time you will get 1 by x, one time you will get 1 by negative x. Right? 1 by x when you have x greater than or equal to 1. You will get 1 by x when x is greater than or equal to 1. You will get negative 1 by x when you have x less than or equal to negative 1. Please remember, I told you, I explained you already. And ax square plus b, if you have x between negative 1 and 1. So you have all the areas covered now. So depending upon at which value you have to check, you will use this function accordingly. This function, you can add 1 by x when x is greater than or equal to 1. Okay. Let us see how it turns out to be. So I'm just cleaning it up. I hope you got the explanation now. Now it is easy to solve. Now it is easy to go on with these discussion under our belt. So limit x tends to 1 minus, limit x tends to 1 plus. We are going to check at 1 because it is already said that the function is continuous and differentiable. So when you go on the left, remember I just told you, when you are on the left of 1, just a bit left of 1, you have to use ax square plus b. I am doing the continuity right now. When you are on above 1, that is x is greater than or equal to 1, you get 1 by x. right? So x is greater than or equal to 1, you will use 1 by x, right? Now, if you see, if I apply x limit 1, I am not getting any value which is division by 0 or any value which is undescribable, indeterminate or not found or not defined, nothing like that. Because the values which are undefined are especially those which are divided by, you get a division by 0. So ax square plus b 1 by x, I am applying 1 directly here. In place of x, I am replacing it by 1 or putting 1 in place of that. So a plus b and 1, when you know that it is continuous, a plus b equals 1 because the left hand limit and right hand limit are equal. So first equation is a plus b equals to 1. Okay, I am clearing it again because we are talking about the differentiability now. A plus b equals to 1 is the first equation that we are going to use just now. At x equals to 1, now we are gearing up for the differentiability. Fx minus fc divided by x minus c, and limit extends to c. c is 1 here. What is 1? c 1. f1 is what? Please remember, I told you the equality also. It was 1 by 1, 1 by x. So if you replace x by 1, it will be 1 by 1, that is 1. So in place of f1, we are going to put 1. So this actually function, which is the differentiability function, fx minus 1 divided by x minus 1, this is the simplified version we are going to use. So we'll go to the left hand derivative, we'll go to the right hand derivative, and we have used fx on the left hand limit as ax square plus b, that we are going to use here also. On the right we have used fx as 1 by x, we are going to use it here also. So I hope you got the idea. LHD and RHD, that means on left of 1, on right of 1, on left of 1, fx becomes ax square plus b, minus 1 was already there, divided by x minus 1. On right, what do you get? See, limit extends to 1 minus and limit extends to 1 plus have to be written by you. And when you go on 1 plus, you have 1. So 1, this is 1 by x minus 1 divided by x minus 1. So let us resolve them and try to find out another equation. So in order to solve this, you don't get anything to get it cancelled by x minus 1. So we'll use this a plus b equals 1. In b minus 1, it will be negative a. A plus b equals 1, that means b minus 1 equals negative a. So in this b minus 1, we are going to replace it by negative a. Okay. So let us put it here, b minus 1, you just replace it by negative a. So ax square minus a divided by x minus 1. You can take a common, x square minus 1 divided by x minus 1. A into x minus 1 into x plus 1, it is equivalent to a square minus b square. So you have a minus b, a plus b divided by x minus 1. X minus 1, x minus 1 get cancelled. You have a into x plus 1. Now limit extends to 1 or was already there. You can apply the limit. You can replace x by 1. So a into 1 plus 1 is 2a. The left hand derivative have given you 2a. On the right hand derivative, you have 1 by x minus 1. So it will be 1 minus x by 1 divided by x. So you have 1 minus x divided by x, and here you have x minus 1. You can cancel 1 minus and x minus 1 because you will get a negative 1. Because these are not same. You have to have multiplication by negative, then only you will get it. So you have a minus 1 by, see, this x, minus 1 by x you will get. So minus 1 by x, now apply limit extends to 1. In place of x, replace it by 1. You get 1 by negative 1, that is negative 1. So what do you get? Negative 1. Now as the question is saying that it is differentiable, so the left hand derivative and right hand derivative will be same. So 2a will be equal to 1. A will give you negative 1 by 2. Minus half. Now a plus b is equal to 1. So you can just replace a by negative half in this. A minus half plus b is 1. 1 is b is equal to 1 plus 1 by 2. That is going to be 3 by 2. B is 3 by 2. This is your option. The second option is the correct option. Okay. So this is how you are going to solve it. This is a bit tricky question. If you understand 1 by modulus x, all these, it will be easy. Now this question also we have covered, and you can just go back to the other exercises of this chapter and you will be able to find this question. Because it is not going to take a lot of time, so I can give you one more explanation. So you just have to think that this greatest integer function will always give you the value which is the least integer. That is, and please remember there is one more function which is the lowest integer function. You have a ceiling and floor like that. These functions are nothing but ceiling and floor only. So you have x minus greatest integer function. I will call it as GIF. So this, if you have n and n minus 1, I'm just trying to show you how graphically you can understand it. So if I make a line and you are between 2 and 3, the GIF function will always give you the lower integer. Okay? If you are between negative n minus 1 and n minus 1 and n are not included, because n minus 1 is included here, n is not included. So if you are between 2 and 2.999 something, you will always get 2. So x minus modulus of x, if you are between n minus 1 and 1, that is 2 and 2.999 and something, you will always get 2. How do you get this? The GIF function will give you n minus 1. That is 2.3 will give you 2, 2.6 will give you 2, like this. So x minus n minus 1 you can write. Right? So 2.2 will give you 2, 2.6 will give you 2, 2.99 will even give you 2. But when you are between n and n plus 1, assume now you are between 3 and 4. And 3 is included always. So when you are between this, if you are between 3 and 4, n and n plus 1, then what value you are going to get? Again 3. The same logic goes. If you are between 2 and 3, you will get 2. If you are between 3 and 4, you will get 3. So if you are between x is between n and n plus 1, you are going to get the GIF function as n. This one here. N minus x minus n, sorry. Now when you are exactly at an integer, the x and modulus, the GIF function will be same. X is also n. The greatest integer function will also give you n. N minus n is 0. Right? So you will get a 0 here. Right? Now, all these are clear now. So let us take the left hand limit and right hand limit and check it at certain n now. Left hand limit, right hand limit, check it at n. And you have to put x as n. Right? So x minus n plus 1, this is what you have to use in left hand limit. Right hand limit you have to use x minus n, as I told you right now here. You are checking at n. So x minus n plus 1, if you apply the limit x tends to n here, on the left you will get n minus n plus 1, that is 1. On right you will get n minus n, that is going to 0. So 1 and 0, LHL is giving you 1, RHL is giving you 0, that is not equal. So this function is not continuous. You will not even talk about differentiability because it is already saying that it is continuous, not continuous at integer points. But what about non-integer points? At non-integer point, it will be continuous. We have checked at x equals to n. But when you check at some value that is 2.2, 2.3, 2.8, then you will get the left hand and right hand limit as same. Okay? So if you remove 2.2 minus 2, you will get 0.2 here. On the right also, if you do this, you will get a 0.2. So if the function this is only continuous at non-integer points, it is discontinuous at integer points, because in non-continuity I showed you at x equals to 1. But because of the function of this GIF function, greatest integer function, it is very clear that it is continuous at non-integer points but discontinuous at integral points, which is n, which we have showed taking x equals to n. 1 on the left hand side we got 1, on the right hand side we got 0. Okay? So I hope you got the idea of this. If you want to learn more, then we have already discussed it in the previous exercise. So you can just have a look. Okay, this question we'll take in the next discussion. Till then, thank you so much. Take care of yourself.